Hello everyone. In the last videos we had gone through the basics of electrochemistry, which includes conductors and types of conductors, conductance and types of conductance, and effect of dilution on various types of conductances, and Kohlraasch's law. In this video today I am here with the concept of electrolysis. Already I told you that electrochemistry deals with the conversion of electrical energy into chemical energy and conversion of chemical energy into electrical energy. Now electrolysis is nothing but a conversion of electrical energy into chemical energy, right? So electrolysis. Already I told you electrolysis is nothing but conversion of electrical energy into chemical energy. It is nothing but conversion of electrical energy into chemical energy. Before we are going to learn about electrolysis, let me clear one thing, that conductors are two types. One is electronic conductors and the other one is electrolytic conductors. Electronic conductors, examples for electronic conductors are metals. Examples for electronic conductors are metals. Electronic conductors, examples are metals. Metals are electronic conductors, and the second type of conductors are electrolytic conductors. Electrolytic conductors, right? Examples are aqueous solutions of acids, bases and salts, and moreover fused salts, right? I already told you that electronic conductors, there is no chemical reaction during the passage of current through electronic conductors, but when we pass or when we are passing electrical current through electrolytic conductors, there is a chemical reaction takes place. So when we pass electrical current through electrolytic conductors, there is a chemical reaction there. In electrolytic conductors, chemical reaction takes place, right? Okay. So and one moreover, fused salts. What is fused salts? Fused salts are also examples for electrolytic conductors. What are fused salts? In general salts are in solid form, in which ions are not free to move, as they are held together by electrostatic forces and do not conduct electricity. But whereas in the fused state, In the fused state, solid melts and to give free ions and conduct electricity. So, fused salt is neither a solid nor a liquid. It is miniature version of solid and liquid, and it conducts electricity. Therefore, fused salts are examples for electrolytic conductors. Right? Now, we shall go through the electrolysis. Electrolysis is a complex word. Electrolysis is a complex word. Electrolysis is a complex word which includes two words, that is electro plus olysis. Olysis. Olysis means decomposition. Olysis means decomposition. Olysis means decomposition. And electro means by EMF. By EMF, that is electrolysis is nothing but decomposition by EMF. Decomposition by EMF. Now, let us define the electrolysis. Electrolysis is decomposition of a chemical compound in the fused state or in the aqueous state or aqueous solution state. Right? So, electrolysis is decomposition of a chemical compound into its constituent elements by the passage of applied EMF or passage of applied EMF or under the passage of applied EMF. Therefore, electrolysis is decomposition of a chemical compound into its constituent elements by the applied EMF. Right? Okay. So, already I told you electrochemistry, the subject electrochemistry deals with conversion of electrical energy into chemical energy. Okay. Electrolysis, what happens in the electrolysis? We are supplying EMF. By that EMF, we are decomposing the chemical compound and to produce chemical species or elements or constituent elements. Right? So, to execute this electrolysis, we need an arrangement. We need an arrangement, that is electrolytic cell. So, to execute electrolysis process, we need an arrangement that is electrolytic cell. So, if you want to perform electrolysis process, we need electrolytic cell. We need electrolytic cell. What is meant by electrolytic cell? What is meant by electrolytic cell? Okay, let us learn about electrolytic cell, then we go for electrolysis. Right? Electrolytic cell. Electrolytic cell consists of one container. Electrolytic cell consists of one container to pour electrolyte. To pour electrolyte. Okay. So, electrolytic cell consists of one container to pour electrolyte, and it consists of two rods, usually platinum rods. Usually platinum rods. Usually platinum rods. Right? It consists two rods, usually platinum rods, to conduct electricity. And in the electrolysis, we are supplying electrical energy. So, we need a battery to supply EMF. We need a battery to supply EMF, right? These rods are called electrodes. One electrode is cathode and the another electrode is anode. Cathode is being represented by positive and anode is being represented by negative electrode, right? So, right, or negative, positive, or whatever it may be. You can take this is positive and this is negative. Okay, so right. So this is called one electrode and this is called another electrode. So cathode is positive electrode, sorry, cathode. Cation means positive, okay, no need to confuse. Cation means is a positive ion and cathode is negative electrode, right? Anion is negative ion and anode is positive, and anode is positive, okay, right, okay. So cation is positive ion and cathode is negative electrode. Anion is negative ion and anode is positive ion. So here the anode is positive electrode and cathode is negative electrode, okay, right, okay. So electrolytic cell consists one container to pour the electrolyte and it consists two electrodes. Usually platinum rods are used as electrodes, and we need a battery to supply EMF, right? This is called electrolytic cell. So what happens, and we know that electrolytes, examples for electrolytes are fused salts, aqueous solutions of acids, bases and salts, right? So let us consider the fused KCl or molten KCl as electrolyte. Let us take fused or molten fused KCl as electrolyte, fused KCl as electrolyte, okay. Now a fused KCl is a lattice, it dissociates as 2KCl gives rise to 2K plus and 2Cl minus ions. So KCl is a lattice and that dissociates, because KCl is in the fused state. Fused state means that solid melts, and upon that melting that dissociate to give free ions, 2K plus ions and 2Cl minus ions, right? So fused KCl dissociate like that, right, okay. So when we take fused KCl as electrolyte, then we are supplying electrical energy, through battery. We are supplying electric energy, we are supplying EMF, to the electrolytic cell through external battery, okay, through external battery. So battery supplying EMF to this electrolytic cell, and due to that EMF this fused KCl fused KCl dissociate into free K plus ions and Cl minus ions. Whenever we pass EMF to the electrolytic cell, these K plus ions and Cl minus ions undergoes that is K plus ions and Cl minus ions moves towards opposite or counter electrodes, okay. So K plus, as K plus is being a positive ion, it moves towards negative electrode, right. That is, what is negative electrode here? Cathode. And Cl minus ion moves towards positive electrode. What is the positive electrode here? Anode. Okay, so K plus ions and Cl minus ions moves towards counter electrodes, that is K plus being positive ion, it moves towards cathode, and Cl minus ion is a negative ion, it moves towards positive electrode. Okay, already I told you fused KCl is a example for electrolytic conductor. Already I told you, whenever we pass EMF through electrolytic conductor, that undergoes chemical reaction. Here also KCl and that K plus ions undergoes chemical reaction. When these K plus ions moves towards cathode and undergoes reduction, and Cl minus ions moves towards anode and undergoes oxidation. So at cathode K plus ions that is K plus ions undergo reduction. K plus ions undergo reduction. 2K plus 2 electrons gives rise to 2K. Okay, 2K plus 2 electrons gives rise to 2K. That is, this K plus ion undergoes reduction, that gains electrons. Next, at anode this Cl minus ions undergo oxidation, that is Cl minus, 2 Cl minus ions, stoichiometric equation, I am writing stoichiometric equation, 2 Cl minus ions, it undergoes oxidation, that is Cl2 gas and 2 electrons, that is oxidation is nothing but loss of electrons. So net reaction is these 2 electrons and these 2 electrons are cancelled, 2 KCl, 2K plus and 2 Cl minus gives that gives 2 KCl, gives rise to 2K plus Cl2 gas. That is electrolysis of fused KCl gives potassium at cathode and Cl2 gas at anode. Okay, you should keep this point in your mind. What happens in this? We are supplying electric energy and that converted into chemical energy, that we are getting potassium at cathode and chlorine at anode, chlorine gas at anode. That is electrolysis is nothing but conversion of electrical energy into chemical energy. We are supplying electrical energy, we are supplying EMF and that EMF liberates chemical energy. That EMF produces a chemical energy, that is we are getting potassium at cathode and chlorine gas at anode. Okay, so now let us go for another example. Actually we had gone through the fused KCl as electrolyte. Now we shall take aqueous KCl as an electrolyte. If you take aqueous KCl, now this is fused KCl and now we are going to learn about aqueous KCl, electrolysis of aqueous KCl, and this is fused KCl, right, fused KCl and this is aqueous KCl. Now we are taking aqueous KCl as electrolyte, that is KCl solution. Aqueous KCl means KCl solution in which water is solvent. Aqueous KCl solution means water is solvent, that is why we call it as aqueous KCl solution. So in this aqueous KCl also dissociates as 2 KCl gives rise to 2K plus 2 Cl minus ions, 2K plus and 2 Cl minus ions. Right, now already I told you, whenever we pass electrical energy, that is whenever we pass EMF into the electrolytic cell, in this ions are undergo, and that ions moves towards counter electrodes. Again positive ions, that is K plus ions moves towards cathode, and Cl minus ions moves towards anode. Okay. So, this the electrolysis of aqueous KCl is different from that of electrolysis of fused KCl. It undergoes it differs from electrolysis of fused KCl. What is the difference? This is very, very important, right? So, when we take aqueous KCl as an electrolyte, okay, aqueous means water, here the water is solvent, and water is solvent and KCl is a solute. So, that forms aqueous KCl. So, water is solvent, right. So, actually we are expecting at cathode, we are expecting in the aqueous KCl also, in aqueous electrolysis of aqueous KCl also, we are expecting potassium to undergo reduction, as like in the fused KCl electrolysis. But in the aqueous KCl, electrolysis of aqueous KCl, they at cathode, a different reaction takes place. At cathode, of course, at cathode always reduction takes place, but instead of K plus ions to reduce, water molecules undergo reduction. I shall give you the reason. Okay, let me complete, right. So, instead of K plus ions to undergo reduction, water molecules undergo reduction. At cathode, water molecules undergo reduction. Okay, water molecules undergo reduction, right. Right. Okay. So, at cathode, water molecules undergo reduction, right. But in case of fused KCl, at cathode potassium undergo reduction, but in aqueous KCl, water molecules undergo reduction. Okay, I shall give you reason. And at anode, anode similar to the fused electrolysis of fused KCl. At anode, Cl minus ions undergo oxidation, that is 2Cl minus Cl2 gas plus 2 electrons. Okay. So, why water molecules undergo reduction instead of potassium? Because there is a rule for that. If metal is more reactive, than hydrogen, then hydrogen is reduced. Here potassium metal is highly reactive. Potassium metal is more reactive than hydrogen, because in case of fused KCl there is no hydrogens, because that is not a aqueous solution. But when we take aqueous KCl solution, there exists water molecules. H plus ions are there. Whenever H plus ions, K plus ions, Cl minus ions are in the container. So, if metal is more reactive than hydrogen, then hydrogen reduces first. Right. That is why how can I know this? This can, and you will also you will understand this concept with in a different effective manner when we are discussing electrochemical series, right? So if you keep this point in your mind, when the metal is more reactive, when the metal is more reactive, I repeat, when the metal is more reactive than hydrogen, hydrogen H plus ions reduces, hydrogen undergoes, or H plus ions undergo reduction, right? So that's why water molecules, that is H plus ions, undergo reduction, and that produces H2 gas at cathode. And similarly at anode, as like in the fused KCl, at anode Cl minus ions undergo oxidation, right? But there is a one more important point is there in aqueous electrolysis of aqueous KCl solution. If you continue this electrolysis, that means prolonged electrolysis, after we are getting Cl2 gas at anode, we are continue to supply EMF with the battery into the electrolytic cell, that is prolonged electrolysis. On prolonged electrolysis, on prolonged electrolysis, water molecules also undergo oxidation, that is water molecules also undergo 2H2O gives rise to O2 gas plus 4 H plus ions plus 4 electrons, right? So on prolonged electrolysis, that means after getting the Cl2 gas at anode, we are continue to supply EMF to the electrolytic cell, that's called prolonged electrolysis. On prolonged electrolysis, water molecules also undergo oxidation, that is water molecules undergo oxidation gives O2 gas at anode, and that liberates electrons, that is 4 H plus ions and 4 electrons. So electrolysis of aqueous KCl gives hydrogen gas at cathode, Cl2 gas at anode, and O2 gas at anode, right? Okay. So let me compare with fused KCl. So with fused KCl electrolysis gives at cathode potassium deposits, at anode Cl2 gas liberates. But aqueous KCl solution, aqueous KCl electrolysis, at anode, at cathode H2 gas liberates, at anode Cl2 gas and O2 gas also liberates at anode, okay. And moreover, you should keep this point in your mind, because this is very important. Fused electrolysis of fused KCl gives potassium at cathode, chlorine gas at anode, right? And electrolysis of aqueous KCl gives hydrogen gas at cathode instead of potassium deposition, and Cl2 gas and O2 gas at anode, okay. And moreover, one more most important point is there, that is aqueous KCl, electrolysis of aqueous KCl includes electrolysis of water, because water undergoes reduction as well as oxidation, water undergoes oxidation as well as reduction. Okay, let me explain with so water electrolysis of aqueous KCl includes electrolysis of water, right? I repeat, electrolysis of aqueous KCl includes electrolysis of water also, okay, because we can understand that water molecules undergo reduction, at the same time water molecules undergo oxidation, okay. So water molecules 4H2O plus 4 electrons gives rise to 2H2 gas plus 4 OH minus ions. This is reduction, water molecules undergo reduction, and water molecules undergo oxidation, that is 2H2O plus 2H2O gives rise to O2 gas plus 4H plus ions plus 4 electrons, okay. So net reaction is 4 electrons get cancelled, okay. 6H2O gives rise to 2H2 plus O2, okay. 4H plus ions and 4 OH minus ions can written as 4H2O molecules. 4H2O molecules. Here left side is 6H2O molecules and right side is 4H2O molecules. So we can simplify this reaction, that is 2H2O. So net reaction is 2H2O. So 4H2O molecules get cancelled. 2H2O molecules remains in the left side, that is 2H2O gives rise to 2H2 plus O2, okay, 2H2 plus O2, right. That means 2 water molecules requires 4 electrons to undergo reduction, right. That means 2 water molecules requires 4 electrons, or 2 moles of water molecules need 4 Faradays of current, that is 4 Faradays. Already we are all know that Faraday is a quantity of electric charge carried by 1 mole of electrons. 1 Faraday is equal to 96,500 coulombs, okay. I repeat, Faraday is quantity of electric charge carried by 1 mole of electrons. So 2 moles of water molecules requires 4 Faradays, because 1 Faraday means electric charge carried by 1 mole of electrons. Here 4 electrons undergo 4 electrons, that is 2 water molecules need 4 electrons, 4 moles of electrons, okay. So that's why 2 water molecules requires 4 Faradays of electricity, and 2 water molecules require 4 Faradays, that is 4 Faradays, and 1 water molecule requires 2 Faradays of electric current, 2 Faradays of electric current to undergo electrolysis. So 2 water molecules, for the electrolysis of 2 water molecules we need 4 Faradays of electricity, right. So for 1 mole electrolysis of 1 mole of water we need 2 Faradays of electricity, okay. I hope you let me conclude this lecture, that is electrolysis is nothing but conversion of electrical energy into chemical energy, right. So we need to execute that electrolysis, we need an arrangement, that is electrolytic cell. Electrolytic cell consists of one container to pour electrolyte, and we need two electrodes, usually platinum electrodes. One acts as anode and one acts as cathode, and we need battery to supply EMF, right? And if you take fused KCl as electrolyte, that gives potassium at cathode and chlorine gas at anode. This is the products that we get at cathode and anode when we electrolyze fused KCl. But electrolysis of aqueous KCl gives hydrogen gas at cathode and Cl2 gas and oxygen gas at anode. Okay, this is very very important. Okay, so instead of potassium deposition, hydrogen gas is liberated on electrolysis of aqueous KCl. That is due to if metal is more reactive than hydrogen, then hydrogen liberates at cathode. If metal is less reactive than hydrogen, then metal is deposited, right? So you shall understand that concept more effectively in when we are discussing, when we learn about electrochemical series, right? And so the products of electrolysis of aqueous KCl gives hydrogen gas at cathode, and at anode we get chlorine gas and oxygen gas. Okay, and one more thing is that electrolysis of aqueous KCl includes electrolysis of water also, because water molecules undergo oxidation as well as reduction. Okay, so that means two water molecules, net reaction is 2H2 gives rise to 2H2 plus O2, and that 2 moles of water molecules and to electrolyze 2 moles of water, we need 4 Faradays of electricity, or for 1 mole of water we need 2 Faradays of electricity. I hope you understand this lecture. Thank you for watching.